Welcome to the AI Research Roundup. I'm Alex. Today we are looking at a paper from the Hugging Face trending list, published on August 20th, 2025, which means it came out just yesterday. The standout result is a system that turns raw point clouds into editable Blender Python scripts, delivering higher reconstruction accuracy while keeping every shape fully programmable. The paper is titled MeshCoder, LLM-Powered Structured Mesh Code Generation from Point Clouds. And as we will see later, the implications for 3D editing and automation are quite significant. Beyond accuracy, this paper introduces an expressive Blender API library, a massive object-to-code dataset, and a multimodal model that enables intuitive geometric and topological edits through simple parameter tweaks. Also, the authors shared a GitHub repo. It is the official implementation for MeshCoder, with a README stating the project page and a timeline to release code by November 2025. You will find basic repo metadata, a figures folder, minimal commit history, and no releases or packaged code yet. Alright, this figure gives a quick visual tour of the system's scope and output. The top panel shows a diverse indoor scene, signaling that the generator covers many categories, from furniture to appliances. Below, the left images illustrate a point cloud for a dishwasher and the corresponding reconstructed mesh with visible internal parts, while the chair and jar examples show point cloud inputs side by side with clean, part-segmented meshes produced by the executable code. Now, this figure shows the end-to-end flow from a colored point cloud on the left through a shape tokenizer into a large language model that emits code tokens. The top row highlights the conversion of raw geometry into compact shape tokens, which capture structure for the model to reason over. The bottom panel displays the generated Blender Python, including object and part names, so edits can target specific components. Together, these panels make clear why the outputs are both executable and modular. Building on the pipeline, this figure catalogs the core shape families that the Blender API can generate, with meshes on the left and representative code on the right. We see primitives like cubes and toruses, then translation sweeps that extrude a two-dimensional profile along a path. Next come bridge loops that connect curves, followed by Boolean combinations, and finally arrays that duplicate parts. These families matter because they cover both geometry creation and composition, enabling complex multi-part objects. Next, this table reports quantitative reconstruction performance, so you can compare methods across categories. The left block lists chamfer distance in 10 to the -2 scale, where lower is better, and MeshCoder shows the smallest values in every column. The right block lists intersection over union, where higher is better, and again MeshCoder leads for lamp, chair, sofa, dining table, toilet, and overall. The consistent gains suggest the code-based representation captures both geometry and part structure effectively. Moving from the metrics to the bigger picture, two takeaways stand out. First, turning point clouds into editable Blender Python unlocks precise reconstruction and simple part-level edits through parameters. And second, the expressive API plus large dataset drives consistent gains across categories. Thanks for tuning in. This is Alex from AI Research Roundup, signing off.